with your students?
I think it's good. We have connected the two students who are surely going to finish Khan Academy, but the other one, I think they need to work a lot because some of them are really, I don't know if they are, I mean, I did the evaluation on some of the weeks, and the first weeks are more or less are good for everyone, but the last one, I mean, I haven't seen any documentation, so it can, I mean, it surely is because they still need to document it, but I mean, it's still some work to do. And then on final projects, I know I spoke with Frederick about his final project, and I think he's good to go with his final project. I haven't heard from Ludovic, and so I'm not sure how he's moving on the final project. Guillaume, I spoke with him yesterday, and he's going to. He said, I mean, he has very little time, but he is going to finish it.
Okay.
And Pon also is, I mean,
Chapon?
she is committed
Hi.
to finish. Hello, Pon.
Good. How is Pon? Is she in line or is she behind?
Is she?
Behind or is she aligned with these two guys, Tomas and Roberto?
Uh, well, I mean, she need to do some work on the final project for sure, and she has a lot of catch up to do. But I
Okay.
guess
Okay.
we can do it, right?
Okay. Okay. Which week we had?
Which
This week was on.
this week was the intellectual property.
Okay. Okay. Allora, let's only talk about the final project. The three of them, so fun. Tell me a little bit about the development of the final project. Let me check.
Oh,
How's it going? Do you
so
have?
um, I haven't worked since I left Canada to do my final project. Um,
Mhm.
Mostly catching up the weeks. I talked to Saverio concerning me using Adafruit, and there's like some module. Somebody's doing some noise. It really hurts me. Um, I'm using some Adafruit Shield. I saw that there was some Eagle file, but in the Neil's PCB list, there is some MotoShield simple ones that I may use. So I'm doing some research to do really basic stuff. And for the shapes, they're already drawn. What I would like to do is that going to Sketch to use Rhino, because then I can master a 3D software. So I talked to Saverio on bringing, I'm not like redesigning the whole thing, but just bringing the pieces into Rhino, and then cut it out and see at the laser cutter and see how it works and ameliorate if need be. That's about
Okay.
it.
Okay.
It's a
Okay. Good.
drawing robot,
Okay.
right?
Good. Let's do this.
So
Let's
I
try. Do you have any model or any prototype to
any
show?
prototype.
Uh huh.
If you go on the website on my final project,
Mm-hmm.
you will see that I
Mm-hmm.
assembled it. I did like with the other fruits. Like I assembled it already,
Mm-hmm.
but then it was like my friend's design, and he was just showing me, like we did it quickly so that this is all new for me, so that I know what it is. So he showed me some basic code in Arduino to test if the motor works, how to plug in the motor and all that before I left. So the prototype is using Adafruit and uh, at Arduino Uno, and
Uh huh.
So what I'll do is that I'll take those files that are in SketchUp. You can
Mm-hmm.
see I use the Adafruit Shield
Mm-hmm.
and I did some basic Arduino just to make the motor turn. And then I put it on the wall and assembled the pieces. I did some research. But then yeah, so final project will be like redraw everything, cut everything. Like some of the piece got lost in the from Canada to France, so I have to recut everything.
Mm-hmm. Okay. You know that you need to do your own Arduino, right?
Yes, I did my
We cannot
subject.
use a commercial. Okay, good.
Yes.
Good, good.
So I will use the shield from Neil's list, test it out. But this week
Mm-hmm.
I'm trying to finish all my classes this week and
Okay.
starting my final project next week. And this week in output, I will do the shield for my stepper motor.
Uh-huh. Quite messy, eh? Here.
Yes, I think something happened in the code menu.
Okay. I also I don't think it's of any relevance to write down on the menu, but those are just little details. Let me understand. Well, programming, molding and casting, you have to do it. Output, composite, interface and application. Okay. Okay. Okay, this is the last one that we need to do. The final project is, to be honest, it's nice. I think also as a learning project, it has several topics that can be useful now, that can put you in the condition of playing with electronics and also have some nice output. I always like drawing machine. In fact, I want to show you an exhibition that we just did here in Yak. Uh, Give me 1 second only.
Aldo. Aldo. No, they're gone. I don't know what's the noise that is making.
What?
I
What
You
is it?
got some, I don't know, you got some strange noise like tut 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 tut, tut, which is very, very loud and destroys our ears.
But what, me?
Now, here. Can you hear it? You can't hear it?
yes.
Me
Yeah,
no.
it's from you, Aldo. I don't know. It's like something going tut 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 tut, tut like I don't know, vibrating or touching. I don't know. Whatever.
Now
We'll live with it.
now you hear it now?
Now not.
Okay.
Okay.
Give me 1 second only. Do you see the screen?
Yes.
Okay. Okay. Look, that was the exhibition. Those are all drawings connected to the use of public spaces, and they are all done with robots. So it's actually kind of nice the process. Some of them, like I guess this one, yeah, this one was nice. This is the imagine. This is a sphere, and they created a panel and they put the sphere inside, let's say, a box, and this sphere was filled with ink. So they use this instrument to map the movement of the metro line, and I mean, that was kind of a map that then we used to generate some other calculation. But there are some videos I want to show you. I'll try to find it because I mean that one was more analog as a. Look, for instance, this is another one, which is playing with the wind and natural forces. So basically, there is a sensor, no, and it's recording the wind, and the more the wind is pushing, and the more the servo is rotating.
Mm-hmm.
And at the end, you have this kind of. There are several. There are. Look, I would like to. I will send you also the complete video from it, which is nice.
So they're
Okay.
using some algorithm to like
They are using a
generate it, like
sensor.
winds and algorithm, and then it'll draw in something.
Okay. Basically, there is a sensor. There is a remapping. Is remapping. Let's say wind, and the wind direction, and according to this, the servo that you see on top is rotating. Okay. So it's kind of a translation of the physical aspect converted to a digital input. It's output. Sorry. Okay. It's let me see if that was with me. I don't remember.
But what I'm wondering is how is like the wind blowing east makes a round. Like you have to tell them, right?
It has a set. It's wind, it's the sun radiation, it's sound, whatever is the input, okay, that is recording from environment is converting this input in rotation on the servo motor, okay.
Hmm.
So I mean it's kind of nice, and this is something that you can also apply to your robot.
Yes, that's nice. Wind and sound is good.
Yeah, wind, sound, solar radiation. There are several input that you can use. So I mean, at the end, it's a process that is informing also um, your project. No, it's not only a machine that is moving, but it's moving according to some specific relationship that is generating with the environment. Okay. Good. Let's. Savile, any comment on the project?
The only comment I have is that it's very, very late, and Pana's got a lot of work to do. So that's why I just said, okay, do this project, and I didn't tell her to like change anything or add features, because I'm afraid that at this point you don't have time to implement too much. It could be something that I mean, in your past week exercise, you have to talk about the future of the project and how you are going to evaluate your project. It could be something that you say, my project to be successful must do at least this, and this, and to be like in the future, or if I have time, or if I'm very good, or if anything can be implemented, it could be connected to a sensor and do these other kind of have these other kind of features. So you can use this idea from Aldo as like a stretch goal, okay?
Okay.
In my opinion. Only because I mean we have a short time, and you have to
Well,
have
they.
something that works, okay, and then you can no, but yes, I mean
No, but you're right. I mean, in the logic of this famous spiral development, first she needs to achieve all the other goals, and then she can add this extra information. But I guess it's quite important to have. Ciao, Mattia.
yeah,
Good morning.
definitely, yeah.
Ciao.
Ciao, Mattia.
Okay, good. Romain,
Thank you.
Yes,
you're
I'm here.
welcome.
Welcome.
Romain, how's it going with the final project?
So, what I did, and how is going the final project. In final project, I resolved one of the problem that I had, is that the component max 3100 is not represented anywhere in Eagle library. So I create my Eagle library for this. and I explained it. If you will open my page, I did some updates on it. Or you want me to share the page, or we cannot hear you because you cut the microphone.
I'm moving. I'm going there. Saverio got it. It's noisy, eh? Saverio. If it's noisy, block me. Eh? I'm gonna share the screen.
You can cut microphone, but you can't reactivate them later.
Okay. Okay.
Sorry.
So I did a small update on my page. So you can see on the top now tips and tricks. On the right. And I started to give some tips and tricks that I sorry, just go down.
Okay.
The link is just down on the bottom page. And I started to add some information about how to do things that we don't discover during the work. For example, the multiple PCB. So if I need to cut multiple PCB, and I create the tips how we can cut the PCB from Eagle, we create once, and then we multiply it to print it in one shot. Then I did the second one, how we create the new component in Eagle library. So it was one of the problems that I had, is that Max doesn't provide the Eagle library, so I need to recreate the Eagle library to use it in my final project. So I did this. If you will click on them, you will see inside the explanation and just the step-by-step instruction that explain how we go from the datasheet up to the ready package inside the Eagle. So finally, I can use it, and you can see in my just below you can see the part of my final project. This is the schematic that I integrated from my library. So then what else I worked? I finished it. Normally I finish it. I nearly finished it all my weeks. I didn't yet done the laser cut. I saw that so not laser cut, but needle cut. I saw that Saverio make update about it. You can click on the week 4, for example, just above, yeah, just here. So, for example, here I updated my project by how to use the Roland machine, and so on and so on. And I still need to document 3 weeks. I did it, but it's not yet documented. I did the output device. You just go down, and then it's the update. Yeah, here is all the process of the using the Roland, the workflow, the what kind of mistakes we can have, and so on and so on and so on. So I still need to document output device. It is done with LED, small OLED display. Input device, I had done my oil moisture project that I was supposed to do in the beginning. So it works. It's not yet documented. I will need to update the documentation of this. And the network and communication also, I need to document. I also did it, and I discovered also that some mistakes in E2C boards that presented in these courses. So about my final project, I started to make the PCB. I started to design my PCB, and I'm waiting tomorrow for Fabien to discuss about the problems I have. In fact, I need to discuss with him about the some components that I don't really understand how they work, and some splitting of the boards on the multiple boards, which way is better to do, and the usage of the batteries on variable page. I don't know if the lithium polymer battery we can use, or it's preferred to use another type of battery, and so on and so on and so on. So I need to close these questions tomorrow, and then I start to. And yes, and we have make a shopping list.
I'm not mute. I thought I was mute.
No.
Okay, okay. I was not commenting anything. Everything looks good.
The real prototype, Abdul, the real
Exactly.
prototype will,
You
will
know
be,
where I was going.
yeah, I
Yeah.
understand, I understand. But the real prototype, it will be beginning of the next week if we will receive the components.
But
Tomorrow I will.
why we don't have a model of it?
Sorry?
Why we don't have any digital model already? Apart from the fact that we have all the weeks already almost done.
Yeah,
So.
I understand, I understand. But yes, I concentrated to finalize the weeks. And the model, in fact, I want to do the model when I know something about the size of my prototype. And the size is linked of the battery and the splitting of the PCB on the parts. And these questions I will have answers tomorrow. So after tomorrow, I'm ready to do my prototype of 3D modeling, if it will be a bracelet, if it will be something variable, and so on. So normally, for the beginning of the next weeks, I will have the 3D prototype and understanding what kind of variable it will be, and I will have the working electronics for my tests. It's beginning of next week in my plan.
Okay. Good. No, I mean everything is looks under control, and I love I love your documentation, and I think the tip and tips it's just the perfect addition to your page. It's very good, and I mean this page can be an example for all the other students as well.
Roman,
Thank you. Yeah.
I just hope that for the final project, still the result is going to be as you imagine, because I still only can see some drawings. I don't see any
I will,
development.
I will, I will, I will. It is in
Because
progress.
I know, but I don't even see any test about the lights, and we said that that was a delicate topic. Now, I mean, we are talking about 2 weeks. When are you going to present it? The 20 to 24?
So, sorry, 20,
20, what day is it? The
22.
22. Okay, 22. Perfect. Okay, my God.
one question, Roman. Did you? I love the tips and tricks, blah blah. You linked. I mean, when you are in your week, when you are talking about the thing that you wrote in the tips, you added a link, of course, from the single week.
Okay, I will. I will check.
Because otherwise, I mean, if no one
Of course.
knows that there is a trip and
I
trick
understand.
page, they will never get
I
out
understand. I
Okay.
understand. Yes, I will.
No, I mean, all these things are good, but I want to start seeing
It's the
something
final
on top.
project arriving.
Okay, good. Let me see my schedule. Uh, I will be. I'm starting now a camp. So from the 14th to the 23rd, I'll be basically out. I'll be in Sonar, in industry, and it's gonna be a little bit complicated for me. I mean, you are all invited, but I guess you're gonna be busy. We are coordinating the pavilion, let's say a new exhibition that is connected to additive manufacturing. And this exhibition in Barcelona is called Industry, a global hub for innovation and so on. I'm not sure if Mathieu is participating for sure. He's gonna have a space probably there. He should have, right? No? Yes? Matt, I cannot hear you. It's off the microphone. In any case, okay. Every lab that is in Barcelona or around Barcelona is going to be represented. So I guess yours is going to be there as well, no?
Well, I don't know. I asked Thomas how I need what I need to do to be there, and it wasn't too clear.
No, I saw that Mariona. Okay, whatever. Mariona invited you, so
yeah, I received an email.
Okay.
It wasn't clear what was. Okay.
It's kind of crazy, but apart from this, what I want to say is that I want to check your work. So we're gonna talk again on Monday 13, and then we're gonna talk again on Monday 20, which are 2 days that I'm not in this event. So we switch from Wednesday to Monday, since you're gonna also be free and you're not gonna do you don't have any week to prepare. You need to prepare the final project. The review, it's only connected to the final project. Okay, who is behind needs to catch up with us. So we will have the review on Monday at 10:30 and both days on the, as I said, the 13 and the 20. Okay. So on Monday 13, Phone, Romain, and Thomas, now we'll check with you. Everyone is going to present the final project. Va bene. Ciao Lorenzo, welcome to the regional review. Thomas, it's your turn.
Yeah, hi. So I let you go on my page, or do you want me to?
No, I will go. I prefer to go.
Okay. So first thing about my final project for me is that I decided to change it a little bit. I discussed it already with Saverio, and I decided to get rid of the mechanical part because it was going to be too complicated and to be too much time consuming for me. So the whole thing of controlling the gears system that displays the minutes on the clock with a servo motor, I just got rid of it, and instead I will use some LEDs as well for the minutes. I prefer to do it because I wanted to focus on finishing the project.
And it was also Neil's suggestion. This.
Yeah, exactly.
During last review.
It looks very elegant, eh?
Yeah, this is the first test I made, and it was already quite good. So unfortunately, I don't have this prototype anymore because my stuff was stolen. So I took a lot of delay in my work, but it's alright. Now I'm working on the LEDs. I received yesterday all the LEDs I need. That I ordered them with Fabien of Let Me Know, and so the LEDs I'm using are they're called NeoPixel. It's made by Adafruit, and it's a little LED with an integrated driver chip. So they are chainable, and it's really easy to pilot because you can just connect many LEDs together and pilot them with only one pin of your microcontroller. So there's an Arduino library which is provided by Adafruit as well, and so it's really easy to control. So I will have 12 of them for the hours and 60 of them for the minutes. So it's a lot of soldering to do and a lot of PCBs to mill. So I began yesterday to mill the first one to make a test. Which
so
you can see on the...
You don't have this part anymore.
No, I don't have this part anymore. Yeah. If you want, I can explain why I didn't keep it. It's just
I understand, I guess.
Yeah. Okay, so
if you want to explain, I mean, I understood it's not it's adding an extra layer that probably we can simplify, no?
Exactly.
Or not?
Exactly.
Okay, go on.
So if you go on the electronics page, this is the mechanical page, and there's the other side, which is electronics. I took some pictures and I did a little test with the LEDs I received yesterday, and so my goal basically is to mill one little board for each LED, and on this little board I will just put the LED plus a capacitor, because they recommend on Adafruit to use a capacitor for each LED, for each NeoPixel you use. So that's what I'm doing now. I already did a test with one single board, and for the hours I will have like a ring that I will laser cut in plywood, and I will have 12 of these little boards on it, which I will connect with some wires. And for the minutes I will have to mill I think 10 segments, which are little boards that include 6 LEDs each, and so I will have 60 of these segments, and it will make a ring also when I will connect them. So it's a lot of milling to do. I'm not sure for the moment we have enough PCBs, but we will receive some more, I guess, soon. So here, yeah, this is the work. What you can see here, the circles, the blue circles, that are the rings that I will laser cut. And so I will engrave the places of each LED to know exactly where to place the little boards. And which is tricky as well is to be able to actually have enough space for each LEDs on the minutes one, especially because there are 60 of them. So I just I copied from Rhino the traces of the LEDs, and I imported them in Eagle to have like a guide, and then I did a test placing 3 of them next to each other to be sure that they fit on the ring, and then I did this ring with 6 LEDs, the segment I was talking about, and I will make 10 of them. And this is the test. That's the last thing I did yesterday. So for the LED part, I'm quite comfortable, and I think there will be no problem. And then I will have to work more on the Wi-Fi connection.
When you do a picture like this, just it's good to put a little coin just to understand the scale.
The scale, yeah.
But are you going to cut a bigger piece, like the one that I see here, or those are going to be just separated as one?
No, those were just to make a little test. But afterwards, I will cut like the big segments you just showed.
Okay, is it possible to do it with? I was just thinking now. What if we do it with conductive paper? How it's called? Maquet. Help me 1 second. How it's called?
The copper tape.
Yeah, exactly. Probably can be good and even faster. We can use the
vinyl cutter, you mean?
The vinyl cutter, yeah. Maybe.
Yeah, I think it's a good idea.
Yeah, why not? The thing is, for the moment, we don't have copper tape, so I don't know if it's planned to receive it or not.
We don't have it, and Guillaume was trying to find it, and I'm not sure he did.
Right, okay, it's a plus.
May I say something? I like this idea of the 6 arc, the 6 segment. Why don't you make like a little joint, like a puzzle joint, so like a circle at one end, and you cut a circle on the other one, and so you can just snap them together. I don't think it will be any more difficult, and you will just put some solder on the traces where you join them.
Like toy train tracks.
Yeah.
Okay, I see. Yeah, good idea. I will try this. Okay.
Yeah, it's good. And I mean, it's quite advanced, no? The level, and I'm expecting a beautiful, beautiful final result at the end. Do you have just out of curiosity a model of the final? Yeah, it's still this one, no? More or less, gonna look like this probably.
This one is
Without
updated, so it's quite recent, and it's without
without this part.
the single LED. Yeah. And so what I plan to do is for the minutes, I will have a single pocket. So you normally you won't be able to see to distinguish one LED from the other. It will be like a continuous circle that will be more or less full regarding the time.
Okay, but at the moment we don't have just the weather information, no?
No, my plan is to actually to be able to do it for the final presentation as well. I received yesterday as well the LED matrix I ordered. So it's a 16 by 32 pixels LED matrix.
Okay.
But I didn't have time to test it yet and to see how it works.
Okay, well, in any case,
Thomas,
it's beautiful.
one
We can see it everywhere in the tabs.
I have one question. I don't remember what was your plan with the milling. You plan to you want to mill the shapes into the wood, or you want just to make a pocket and then it's up to the LED matrix to give the shape of the, I don't know, the sun, the cloud, the rain.
It's up to the LED matrix.
Okay, so it must be, I mean, the LED matrix must have a good resolution if you want to show this kind of thing, because I think that when you use the LED through wood, it will get some diffusion, and so you have to take account that even if you have a good resolution, then maybe through the wood you lost some resolution, and then maybe you have to do something bigger, some bigger shape to make them visible through the wood.
Mm-hmm. Yeah,
I don't know,
I agree.
but
And also, what I want to do actually for the matrix is not to make like a large pocket, but I mean I will do a large one for the overall shape, and then I will do little pockets for each pixel.
okay.
You can see on the prototype page. It's quite complicated to have the exact. It was quite complicated to have the exact size and place for each pixel. But now I have the matrix, I can do calculation and measures, and I will do little pockets for each pixel, so I will have a good
Otherwise,
resolution.
you can do something else, like you could do, like, I don't know, 3 pockets. Like one pocket is up. The first one is for where is written Monday 1st February, and that could be each pocket is for each LED. Okay, so you will have some kind of good resolution. On the sun, cloud, rain, and blah blah, you could make a pocket that is the shape of the sun, one of the shape of the cloud, and then use the LED just to light the pocket. Okay, so instead of using the LEDs with the shape of the cloud and the little raindrops, you could just make the pocket have the shape of the cloud and the rain, and then use the LED. Like, I don't know, you just take a square of 4x4 LED, light them up, and then you light up the shape of the sun. Maybe you could do a combination of some parts that you need more resolution because it's a shape with the little details, and another part that is just LEDs lighting up, like Monday 1st February.
Yeah.
You
Okay.
know?
Yeah, sure.
Okay, maybe we will talk about it later.
No problem.
Okay. I mean, look, Matteo, go. Sorry. I see that.
No, I'm really sorry. I have a meeting, and I think Thomas is doing a very good job, and I just wanted to mention that. So I apologize because I have to leave.
Okay. We talk later if you have any problem with the other with Introdu stream. I can ask Mariona.
Okay.
to check the situation there.
I'm going now to Barcelona. Yeah, I can talk later when you're available.
Va bene, okay. Good. Thank you, Matt. Ciao.
Bye-bye.
Bye.
Okay, guys. Good. Lorenz is there, but I cannot see. Lorenz, are you there? Okay. Everything clear? Monday, 13, 10:30, review. We start with the same order, Fon, Romain, and Thomas. Okay?
I showed yesterday to Thomas and Pon about the tutorial I was doing on as a student on Fusion 360, and I think it's very cool. And I suggest you guys have, if you guys have some times, to check it out because it's very nice and free software. So actually, this is just an information for Roman and for Alto.
Sorry, can you repeat the name of?
Fusion 360 is the one from Autodesk.
Yes.
It's like, I think it's, I mean, same idea as SolidWorks, but not as professional as SolidWorks, but with the full parametric, and also there's also version control, so you can just make, if you want to make a change to something you did like 2 days ago, you can just go back, make the change, then go forward, and you have the change made like if you updated 2 days. Yeah, Lorenzo is talking.
Can you hear me?
Yes, yes.
Oh, okay, that's awesome.
Ciao, Lorenzo.
Ciao. Sorry, we got some issue with the speaker, but
The camera.
Speaker and camera. I don't know why the camera is not working. But, I mean, wait. We like the project that your student did with the, you know, the with the lights and the study that he did in order to figure out the depth of the milling with the LED. It was a really cool project, and actually we really interesting to see how it's going on. I mean, how is you know, the development of the first prototype. Yeah, besides that, we have 2 students here. No, they're kind of shy, but we have 2 students and trying to figure out the webcam if it's fine. But I don't know, Fridge, would you like to just explain
my final project?
Yeah,
Sure.
so we have Fridjof that is, I can share the screen of his page, maybe.
With respect to you've just seen, my project is not nearly as sexy. It's I'm from an engineering scientific background, electronics based. Please don't expect any super graphics and sexy designs.
You know that engineers are Neil's favorite, so go on, don't be shy.
Actually, a physicist is much better than an engineer for me, I think.
we just lost Lorenzo.
Yes.
Guys, can I add something while we're here?
Yeah.
It's just because I forgot to tell you, WOMA organized with Ulul, which is a crowdfunding company, call for projects, and I participate to this call for project. And my project, so it's the final project from Academy, and it has been selected among the 15 best projects.
Cool.
So now I have to as well do a prototype for this call for project 2. It's on the 17th to 15th of June, So I will work as well for this project, and I will have to make a crowdfunding campaign for my clock later. So just to tell you.
Very
So
nice.
it's more work and even more work.
Bravo, Thomas. No, you're very good and talented. Good, bravo. But that's still nothing, eh? You need to aim even more on something bigger.
Yeah, why not?
Little by little. Good.
Sorry,
Okay,
Alex is back.
we
I'm
see
back
you.
with webcam also.
Amazing, all the offer, eh?
Yeah.
Va bene, dai. Let's share the screen. You have 3 students, eh? I understood 2.
No, no, at the moment, Mathieu is our stagiaire.
Okay.
Intern, merci, because I'm just switching from French and English, so it's kind of.
It's not a problem.
No, he's a light designer. Yeah, so he was again, he was really interested in your student project. At the moment, I don't know if you want to just like to talk about your sexy project.
My sexy project is a data logger, and what makes this what motivated this project is that I need different kinds of control and logging for a number of different jobs that I do. I need to know flows for different houses that I manage, and we have different gardens, and we need to have valve control, etc. When you go on the internet and you look at the products that control valves and that measure fluids, etc., a lot of them are either very restricted in their functionality and very closed in their ability to be modified, or they are very complete solutions with far more capacity than I require and a price tag that is far in excess of what I would want to spend. And what I was looking for is to build something quite small, quite modular, that's easily extendable and that you can fit a lot of different kinds of input-output devices to. And so what I decided first off is instead of using the Arduino and AVR, was to move to the Cortex system. And I'm using, my designs are based on the ST Microelectronics Cortex implementation. And that already brought up a number of challenges. From a software perspective, the programming paradigm of the STM Microelectronics is similar to the XMega. In terms of it uses structures to define registers, which in a sense makes it much easier than, for instance, the AVRs. But it's a bigger chip and it has more complexity. And from a hardware perspective, the issue is that the chips are distributed with pin pitches that are very tight. And
maybe you can show something to make it.
And Lorenzo loves asking me questions like this right in the middle of a presentation.
Yes, come on.
So, you know where the box is?
No.
This is Lorenzo's special. He does this to me all the time.
Can you give me?
No, it's like show and tell. I have to have my show and tell ready.
Yeah, you should show something to the guys and then make it clear. How far are you trying to go? It's here the camera. Okay, where's the camera?
Wow. So this is the discovery board. This is a standard board like the MSP430 or the Arduino, and there you can see that it's a LQFP48 package, which has a very fine pitch to it. Now the challenge is that this pitch you can't mill with a standard 1/64th inch pitch that Neil recommends. You need to go for a finer bit. And the tool chain I use to produce is Easy EDA with CopperCam. And CopperCam has a functionality to where you can restrict a certain area of the board to be milled with a finer bit than the rest of the board. And we looked at that solution, and the problem was that even if we could mill the pads for the chip with a very, very small bit, you still have a lot of other issues with just getting the traces to run from those pad points onto the rest of the chip. So we nixed that idea, and on the first prototype board, I'm going to give you 2 seconds. I'm going to get this piece because it's really interesting.
Yeah.
Lorenzo, can you send me the link of the page?
Yes, sure.
I'm back. All right. Are they still there?
Yes, yes, you're still there. Sorry.
Yeah, I'm here.
So, can you scoot the camera up?
Yes, yes, yes.
This is an object. This is an adapter, and I'm not sure how well you can see this on the video camera. And what you can do is you can
Perfect, I see it.
chip in this without soldering. And on the other side, it has a regular 2.54 millimeter pitch output. So these are obviously very millable on our machine. So the prototype board, in order to use the very fine pitch, will have this sitting on top of it, and you just complete the chip onto it. And what's really nice is that these pieces a few years ago used to be very expensive. You'd pay upwards of $75 to $100 for one of these. And now on eBay you can get them for about $25, which makes it much more reasonable. And in fact, I have one of these for the LQF48 package, as well as for the LQF64 package, which gives you even more output pins and bigger chips. And once, obviously, it works with something like this, then you can go and export the design to a fab in China and have them produce the design for you. But the other issue you have as well with high-density chips like this is routing is very difficult on one-sided boards. And I even saw this when we were doing the Fab Arduino. We had a lot of problems getting the routing done. And Neil kind of, I like Neil because he sits there and he has these great designs for his AVRs. And you look at the design, and it must have taken someone quite a long time to get that routing because it's absolutely perfect. And if you were to build a board and run it through an auto router, given the minimum trace width and the minimum trace gap, if you will, for the 1/64 bit, most auto routers can't handle that design, especially not on a one-sided board. So that's going to be a challenge as well. I'll stop talking now. Sorry.
No, it's a. No, I mean, no, don't worry. I mean, it's a smart solution, and also it's a good information for the others. In our experience, when we had to do the board for the fab drone, and we had more or less the same issue. It was a double-side mill that we had to do on the board, and we decided to use ACID. So we changed completely the technique, and we didn't mill at all. And we went to the guys that are doing the Smart Citizen here close by, and we just basically used the ACID. That is completely a different method. I'll share with you. I'm sure you have the accessibility to those techniques. Actually, the solution that you found is the only one that you can adopt. No, in this. Let's say in this situation. So okay, that's good. But now 5 minutes for the final project.
This is
that's
the
a
final
good solution. You'll find no. That's the final project. But apart from the electronic part, there is also the mechanical part, or how is it going for the prototype? You know, for the prototyping the rest of the project apart from the board.
Right, and then there'll be an output. So we'll have to write the software, and I'll probably build it for a flow meter. Because
let me go to your page. Sorry, probably it's easier. Okay, I'm on it. Okay, that's perfect. So we just saw the part for the board, which I guess it's completely under control and it's very smart.
Now that's the original project, which went out the window as soon as I realized how complicated it was, and maybe it's at the top of the page.
Okay. Is this partner?
Yeah. No, keep going up. There, that's it.
But I'm but I'm kind of confused. Are you going to apply this on the drone or not?
No.
This
is a standalone project. This is a standalone data logger that will apply. For instance, if you look at this piece, this is a flow meter, and it basically has a. Now I forgot because I need to talk to you about it. Hall effect sensor with an impeller on the inside. That when fluid flows through it, it gives you a pulse, and the frequency of that pulse, given the interior dimensions of the impeller, can be translated into a flow rate. And for instance, what I'll do is I'll write software for the chip that will then be able to interpret the information coming from this sensor and give me a flow rate. And then the other side have an output project that allows me to read that data, either through a serial interface or something more fancy if time permits.
You know, it's a different approach from the usual project that you see, but it's quite fascinating. I would say this specific final project. There is really not such a big physical part that you need to mill or laser cut, 3D print. It's more really about the electronic, the data, and I guess it's kind of you see. I would like to read it more. Actually, it's. I'm just thinking if it's fine for the Fab Academy that we don't have a specific mechanical part out of it. I see that it's not probably very important to have it. But you know what I mean.
To be honest, I thought it's a really interesting project, and also it touched the programming area, some problems, some issues about the milling machine that we had to face during.
Yeah, exactly. Yeah.
And at the same time, it's can I say modular? Not modular, but it's kind of modular. So it some way like follows the philosophy that we have in Fab Academy, trying to doing something that is for multi-purpose. Okay. So I don't know. I mean, from my point of view, it's not practical as most of the projects that we can see in the Fab Academy. But at the same time, it has a really high value for for the future project. I mean, if it's really cool to have some.
So, which one you consider can be the mechanical part of this project? Which one we should consider as mechanical part? The milling process, the strategy for generating the board.
Well, I don't know. To be honest, we can also try to figure out a sort of case to make it better.
I know the case.
Can I suggest?
Exactly. No, I would like you to answer actually.
Well, let me suggest one thing. I'm working on another project. It's not really related to the Fab Academy, but I work with BISA, and we've been working on a hive scale, which is not necessarily a new project, but it's one that has a tremendous value added to the beekeeping community. And while that's not really a part of Fab Academy, it's something that would use a sensor array. It was originally designed to work with the AVR 328P chip and the Arduino, because the people who I was working with, that was their level of expertise. That we can integrate a load sensor into this project as the data input functionality, and that's mechanical.
Okay. And yeah, you see, it's it's really, you know, another way to see it, but for me, it's completely right.
Yeah, we can.
For me, it's a go.
Hmm.
Did Neil saw the final project, or did you have the chance to discuss with him about it?
Not yet.
But I mean, I guess it's kind of, you know, it's a really interesting if you can, if there is a possibility today to do it, you should talk about it with him. You know, and we can, and I want to listen even what's the input, because at the end is, yeah, as you said, it's kind of creating a modular solution that can be applied to a lot of different other projects, no? And,
Yes, yes.
Neil is gonna do some final project review today or what?
Yeah.
I guess so, because
Yes.
if I'm wrong, the idea is like to try to talk with as much as students possible to figure out their status.
Okay, good. And what happened with the autonomous flight? Because I also see that there is this information on the website.
Those are the sort of ambitious projects that I am not the only one who, at the beginning of the Fab Academy, thought that we could rule the world in the 5 months.
Okay.
May I say
that,
something?
yeah.
Hello? May
Yeah, go on.
Okay, for the mechanical part, or the physical part, it could be like you could just say, since this project, you can use it for different kind of things, you know. So you can use it with you can apply it to something, you can apply it to something else. So you could just make examples of where it could go, okay, to what it could be attached or whatever. So instead of like doing one physical application, it could be like you could talk about the different number of shapes it could get or application it could be relied to, or blah blah. And also another thing is about the chip, the gap between the pin of the chip and the thing you are using, this $25 adapter, okay. Also, okay, now you're using this and it's okay, but also in your page, talk about the different solution that one could use. So like using a smaller bit. Okay, now we have the 164, but you could acquire a 0.1 millimeter one or even smaller, and you could do it with that. Or you could use a laser cutter with a fiber source, and you could say, I don't have it in my lab, but I could ask some other fab lab to make me a board with a breakout with pins, and then send it to me. Okay, so I think it's important that since you are saying so much about this $25 thing, that is just, I mean, the project is $50, but the 25 is just for the adapter, so it's clearly a problem, okay? And so talk about, it's okay that you use it, but talk about the different solution that you could use to make it smaller, to make it cheaper.
Actually, we are,
12:30.
in fact, we would like to make a test with some bits that page of Wisely both, and figure out if it works with our mini machine here.
Okay.
Okay. Good.
Just for information's sake, this famous $25, this is not a long-term practical solution to what we're talking about. The long-term practical solution is having the board fabbed and then using reflow ovens to do that. And we have that material here, but unfortunately, it's also just a simple time constraint, because fabbing it out at a reasonable price to China and getting it back here before the end of the fab lab just wasn't doable. And so we chose, and given the problems related to the milling, this is the fastest and most efficient way to actually get something working for the end of the final project run.
Yeah, but think of your final project also as something that in the future, maybe a fab lab on the other side of the world think that your project is cool, and if you don't end up making it a product, okay, and having it made in China or for 10,000 pieces, if there's only the documentation on your website, and there's a fab lab who wants to do your project, they could just download everything and find a way to do it in the fab lab. So you could talk about the ways to make this thing into a fab lab, and it could be using some process that a fab lab is capable of achieving. Okay.
Okay. All right.
Just to complete the
Sure.
information. Okay.
Sure.
Okay, guys, I need to close the regional review. Okay, Lorenzo, if you can, try to talk with me, because I guess this is a specific case that
All right.
it's interesting if we all discuss together.
Yeah.
And yeah, and I think it's also yeah, try to take your chance to present it to all the rest of the network before. And I think doing it, we should, let's see what he said, because the mechanical part can be let's say interpreted in different other ways, as he is doing now. Okay, then as I said before, I will be busy all the next 2 Wednesdays, so we're gonna do it on Monday at 10:30, and we can start with your lab, and then we move to our students.
All right.
Okay,
Right.
I will pick the ones that are a little bit more behind. So let's start with the ones that are behind, and then we go. If eventually the others are more ready, we can also present their work. Otherwise, we skip it directly. You coordinate locally. Okay. It's always 1 hour. Bye, guys. Thank you
Bye.
for the
Bye bye.
for
Bye bye.
participating.
Bye.
Bye bye.